So we measure the weight, and then we got the mean value of the weight, and we got the arrow, standard arrow for the weight. And what if the weight is not our final answer? We need to use that way to calculate our final result. Then we need to propagate the arrow when there is more than one measurement involved. So if we have this function, it's a function to three variables, u, v, w. U, v, w have their own uncertainties. And in this case, how to calculate the error or uncertainty in x, right? We can think about this as a partial differential. So if there's a little change in x, there will be the error in x, dx, that will equal to the partial differential of u plus the partial differential of v plus the partial differential of w. So basically, that little dx, that little change or error in x will equal to the total differential of three variables. So we add this partial differential all together. And this du, dv, dx are all the arrows from the mean of u, v, and w. Okay, does that make sense? So this, I just applied the definition of differential. If we look at the variance, then the variance square equal to 1 over n, and we take all three terms and take the square of that. So if we do some mathematical operation, and also we ignore all the cross terms, we assume the cross terms will be much smaller than the non-cross terms, then we can get the variance square equal to this one. So basically, the partial differential of u times the standard deviation of u, and the partial differential of v holding u, w as constant times the standard deviation of v, and the partial differential of w holding u and v as constant times the standard deviation of w squared, and take the square of all that. And in terms of the standard deviation, since the standard deviation equal to the square root of the variance, so we can calculate the standard deviation just by looking at the square root of that. So you don't need to know every detail about the mathematical operation, but you do need to know the standard deviation equal to square of the partial differential times the standard deviation of that variable square, and the sum all that together and take a square root. The last equation here is the equation you will use to calculate the arrows in your propagated result. So let's see one example here. So we are calculating the molecular weight of an ideal gas from the ideal gas law. That's PV equal to the weight of the gas divided by the molecular weight of the gas times RT. Okay, I need to calculate the M here, the molecular weight, and I can measure the pressure, the volume, and the weight of the gas. And the R is a constant. It's not what we are going to measure. And we can measure the temperature as well. So here I have a pressure, volume, weight, temperature, and the R as a constant. So R doesn't have an arrow since it's a constant. So in this case, we measure the PVWT multiple times, I can get the mean with the arrow of each variables. We have to manipulate the equation a little bit. I can get the molecular weight equal to W, the weight, times RT divided by PV. So I can plug in the mean of each measurement together with the ideal gas constant. Right, so I plug the weight 0.137 here, and that's the ideal gas constant, and the temperature 298, and then the pressure, that's 735. That's basically 0.967 the pressure, and then the volume of the gas, that will be 0.21. So I got 16.47 gram per mole. That's the mean of the molecular weight. So now let's look at the propagated error. So there, look at our measurement. There are 4 different variables we need to measure. So we need to calculate their individual partial differential and add them together. So it should be, so I take the partial differential of W, that give me RT divided by PV, and that's a partial differential of T, partial differential of P, and partial differential of V. Add them all together. So the square, add their square all together, and take the square root of the sum. They'll give me the error of my molecular weight. So I plug in all these arrows and together with the mean. So when, for example, when you calculate the very first term, this term here, we'll use the whatever value for R here, and the T will use 298. And for the P here, we'll use the mean for P, that's 0.967. And for V, we'll use a 0.21. And DW will use the arrow in W. That'll be 0.0002 to calculate the first term, and so on and so forth. Eventually, we got 0.293 as our uncertainty, and then we use the correct significant figure to get 0.3 gram per mole. Then the final answer for this one is 16.5 plus or minus 0.3 gram per mole. So in order to calculate the propagated error, you need to calculate the partial differential of each term and add them together, take the square root.